Shut up and sit down. Shut up and sit down.
Testing. Oh, I think I got sound back now. Now let's see if I actually get video here. Testing, testing. Come on now. I think you can hear me. You just can't see me. Why do things always go wrong? Right at the last minute. There we go. Holy cow. Well, that was challenging and difficult. I don't know why things suddenly went wrong when I hit the go live button, but my camera shut down. Anyways, welcome to the stream. I am KiCad. It's been a while since I've been here. I've been working on this project called VoltGiver. It's a benchtop power supply based around an ATX 600 watt power supply, the kind you would find in the computer. So I spent the last couple of weeks just writing up a whole bunch of code to get the software side of it working and the screens and the displays. Today, though, I'm finally going to actually get to switch into something a little more fun and interesting. I'm going to be actually working on the circuit board. I'm going to be using KiCad to go ahead and design the circuit board. All of this is being based around an ESP32 microcontroller, a little thing like that, which I'll show you in just a minute. And then I got some additional chips called MCP23017, and then there's going to be some headers for buttons or for outputs and inputs, and it's not a lot going on, but there's actually it's not a complicated board, but there's a lot of components. For example, there's going to be 24 well, there's 12 voltage dividers, so that's like 24 resistors right there, and lots more going on. But let's go ahead and just jump into KiCad, and I'm going to go ahead and start working on this board. So I guess first thing we need to do here is pop on an ESP32. Now I'm going to be using my own modified ESP32 that I have in my library. So one of these is mine. There it is, KiCad boards. I'm going to plop this thing right in the middle. So there's my 32-bit microcontroller. So that little thing right there represents this thing right here. As you can see, it's got the USB port on the bottom. It's kind of sitting like that. And then it just lists all of those pins. Now in a few minutes, you're going to see me transform that into a circuit board and a 3D diagram or a 3D image. And you're going to be able to visualize how all of this stuff works. And it's not a complicated board. Like I said, basically all of these pins just go straight out to a resistor network called a voltage divider. And there's a couple of chips, and really that's about it. Not difficult at all. So the first thing I'm going to do here, though, is I've got 3.3 volt and ground, and I actually do need to apply power to this thing. So I'm going to apply a terminal to this. Well, my hair is not happy today, is it? All right, so what do we got? I need a screw. You know what? I have my own screw terminal somewhere in here. Let's go down to the K's, IJK. KiCad, voltage regulators, diodes, buttons, boards. What am I looking for? Where are my screw terminals? Or maybe I only have them as a footprint. Anyway, so let's go ahead and just find a generic 1x2 screw terminal. That should work just fine. Yeah, I'm going to stick one of these on here. So this is going to bring in power and ground to supply all of my voltages for this bit. This is all 3.3 volt circuitry. There's actually going to be a 5 volt side of this, and we'll see what that ends up looking like a little bit later. So here we go. I've got to hit my power. I'm going to go ahead and move this kind of. Now, I'm telling you right now, I'm no expert at anything. There's probably right ways and wrong ways to doing some of this stuff. Like, for example, putting this somewhere. There's probably a right way in our angles. I don't know. I don't even care most of the time. Because this is just me building stuff for my own use and purposes. So I follow my own rules. It just makes life easier, you know. All right. Let's go back and see what we're looking at here. Let's go ahead and put this thing right about... It's going to be supplying power to everything, right? Just about. All right, well, you know what? I'm just going to stick it right. Right there. What the hell just happened? Now I'm going to stick a couple of labels. There's probably not even the right way to do this, but I'm going to do this anyways. Place a net label on here. And this is going to be called 3.3 volt. And this one is called ground. I'm going to have a couple of grounds on here, one for 3.3 volt and one for 5 volts. So I'm just going to do that. That's just going to help me here for now. Put that there. Come back up here. Oh, it didn't stick around. Put that right there. Draw a line here. Come back up here. Alright, so those are connected to the 3 volt and grounds for now. And I'm good with that. In fact, I'm probably going to put another one here, but we'll see what happens once I lay everything out. I might actually call this one like ground B or something. I don't know. It's just going to get me going. Now, so that's my ESP32 microcontroller with a couple of grounds and terminals. Now I'm going to go ahead and I'm actually just going to save everything. And I'm going to go ahead and start the circuit board side of this. This is the schematic side. This is where we have all those esoteric symbols and lines and weirdnesses. But let's go ahead and jump into seeing how we actually build the actual circuit board itself. And that's the thing that we're going to be dealing with in the real world. So up here at the top, I'm going to go ahead and click on, where is it? There it is, generate net list. So basically what this is going to do is it's going to give everything names and sort of, you know, actually create a little file saying, okay, you know, this component's pin here is connected to this component's pin here because of this. And it's just going to go ahead and do all of that, create this little text file, and just sort of saves all of that, and we're done with that. Okay, good. So we just have to do that pretty much every freaking time. Now what we're going to do is go over here to this, assigning our PCB footprints. I thought I did that. Didn't I do that? There. So that's going to pop up this new screen. So now here we have on this main sheet that I was working on is basically just, it's those funny little schematic symbols, you know, like the resistor is going to be a squiggly line, and as you can see, the screw terminal looks like that. But what we need to do is we need to equate these electrical symbols with something that's in the real world that we're going to use in the real world on a actual circuit board, and that's what this step does. So here we have that schematic where I'm going to be adding all those resistors, which are just weird little symbols with squiggles and things like that. And then we go through this little process of connecting those weird little electrical symbols with real world footprints. So the screw terminal, that's this thing up here. If I scroll down on the left panel, what we're going to see is my own little list of things called KiCad, boards, inductors, displays, pin headers. Now somewhere in here is my screw terminal. There it is. No, that's my pin. Where's my screw terminals? terminal blocks. And then over on the left side, so in the middle, I've got this clicked. And you'll see it actually moves this around when I click on these, so I sort of know which one I'm dealing with here. So I'm dealing with that. On the left side, I found my footprint library, which is called KiCad's terminal blocks. And on the right here, I'm going to go ahead and I'm going to click what seems to be the only one that's in there. Ooh. And if I double click it, it's going to assign it. But before I do that, I'm going to go up here to this little view selected footprint, and it's going to pop up a new window and actually show me what this sort of looks like. So now, this is, like I was saying, we're connecting that electrical symbol with something in the real world, and that's this bit. This is actually just what's called like the silk screen. We're going to see this printed on the circuit board, but what's even better is if we click on this, and now we actually get to see a 3D representation of that terminal block. Now let's have a look at something real quick. Where is it? That actually looks a lot like this one. Now I actually made that in a different design. But it looks a lot like this one, and it's going to work good enough for what I'm doing with here. So I'm going to go ahead and use this one. Whoops, I shouldn't have closed that. So I'm going to double click that, and it connects it to there. Now in here, I'm going to go find my KiCad's boards. So I've got the ESP32 Dev Kit C 30 pin, and in here I should have somewhere Node MCU ESP32S 38 pin, 30 pin. That's the one I want. I'm going to double click it, click OK, apply, save, and do all of that stuff. Click OK. All right. Now we're going to go ahead and open that circuit board that we're sort of beginning to work on here. And there it is. This is the raw drawing. Now we're going to go ahead and we're going to import everything that we just did. There they are. Plop them there. Now I'm going to go ahead and, oh, we got to disconnect everything here. Oh. Okay, I'm just going to stick this up here for now, and we're going to do that. And I'm going to go up here and click on, where are you? I forgot what the hotkey is. Alt 3. And there we go. So that's the ESP32 in the real world, which is this thing. There we go. And that's a terminal block. So that's basically the very first steps of building my real world circuit board. Now what's really even cooler about this is that I can actually export this view into what's called a step file. And then I'm going to use this when I go ahead and start on my next step of this project, which is to actually build the actual box that everything fits in with all the connectors, where this is going to be mounted. I can actually build a 3D model of my entire circuit board here, export it, and then bring it into Fusion 360 so I can do my design of my physical box with the actual circuit board in place. That way I know all of my clearances are going to be good and all of the whatnots and the hot sauce are going to be awesome. So there we go. That's basically the initial steps that I'm going to be doing, just a lot. And there's going to be a lot of resistors in this thing. Boy, there's a lot of resistors. Okay, so that's pretty much the beginning. Now, if we look carefully, we'll see that not much is going on here. Let's go a quick step here. I'm going to go ahead and I'm just going to move this over here, rotate it a bit. Over on the left, I'm going to click on that. I'm just going to go here to there, and from here. There. Now we'll go have a look at that again. And now you can actually see it includes the traces, so you have a kind of clue what's going on. It's really awesome that way. It makes life easy when you're dealing with these 3D designs. But in the meantime, let's just pop back over to that schematic. I better go ahead and undo this. Otherwise, bad things will happen. All right, so I've got my, where'd it go? There you are. Now, the first thing I'm going to connect up are my TFT displays. And I've got their pin mappings laid out here, sort of. Yeah, I think that's right. So what I need to do is add a couple of headers because that's what the displays plug into, is just the cables, and the cables will plug into the headers. So I need, I'm just going to count the pins here. I need 1, 2, 3, 4, 6, 7. I need 8 pins plus the chip select pin. So I need 9 pin headers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I need a couple of 9 pin headers. Now, they're all going to connect to pins that are over on this side. You can see MOSI, clock, CSC, and whatnot. They're all connecting over here. So what I need to do is I need to add a couple of 9 pin headers. So let's go into connectors, generic, mounting pin, what? No, generic. Con, 1x2, 1x9s. That's what I said, right? I could go with a 2x9, but no, that's not right. I need 2. What's this? Should be 2 rows, like. Yeah, none of those. There we go. 2x. Yeah, let's just go with a couple of 1x9s. 1x9s. How y'all doing out there in viewership land? Anyways, let's pick a couple of Con 1x9ers right there. I'm going to plug one right here because they're basically connecting to those pins. I'm going to click it out here, but I'm actually going to add a second one right behind it. Now, so I've got my drawing here of connecting all of those pins together. And you can see at the bottom is VCC and ground. These two are connecting to VCC and ground. So I'm going to go ahead and just connect them up. Let's see, that one, it was to VCC. This one goes to ground. All right, now starting at the other side, we have this one connecting to MOSI. I really should update these names. This is not my dev kit, so what I need to do. All right, well, I need to do this now before I get any further. So let's see, how am I going to do this? Not the footprint editor, symbol libraries. Create, delete. I think that's the one I want. There we go. So what I'm going to do here, this is my board. No, it isn't. Do I have HIJ? Where's K? F-I-K. KiCad's boards. I have my ESP in here. My ESP, this is the one. I need to change this. Okay. There we go. Well, I'm just looking up what the new standards are going to be, and then I'm going to explain to you what I'm actually doing, because there is a darn good reason for doing this. Now, let's see here. Where is it? Controller out. Okay, so you see these things right here, these labels, MOSI and MIOSI. Sorry, I'm just moving some windows around so I can see if anybody were to actually chat something, I might see it, but that's unlikely to happen. Anyways, so you see these labels over here. MOSI and MISO, MOSI and MISO. Now, there's a problem here. It's always been a problem, and this problem has been addressed in a lot of areas of technology, except it does linger on in some places. Now, I copied this from another library, I think, and then just updated the labels according to the sheets. And I did this some time ago. But here's the thing. If you don't actually know what I'm talking about, I'm going to tell you what I'm talking about. MOSI and MISO stands for Master Out, Slave In. Master in, Slave Out. Now, these terminologies have been trying to be updated, especially recently, for obvious reasons. However, these labels linger in a lot of interesting places. And now there's an interesting article in Hackaday about this. And it's something I read many months ago. And I just realized that, you know what, this is one of my older designs that I really need to update because I don't want to really be going forward with these. So there is a new industry standards coming out to trying to change some of these labels. So instead of saying MOSI, which stands for Master Out, Slave In, you know, the names are being changed to COPI and CIPO, COPI and CIPO. It basically stands for Controller Out, Peripheral In, or the other way around, which, you know, Controller In, Peripheral Out, and which makes a lot more sense. So I'm going to go ahead and update these labels. Controller Out, Peripheral In. And this one here should be changed to Controller In, Peripheral Out. Now, I'm just wondering if the I squared C SDO and SDI. I don't have those on here. I have SCL and SCA, SDA, which makes sense. CSO, that's chip select. That's clock, transmit, receive, serial data, clock, chip select. Okay, I think I'm good. Let's go ahead and save that and close it. Now I'm going to go ahead and delete this thing. And I'm going to put it back. Actually, I probably could have just updated it, but oh well. There. Now we got the right labels going on there. That's better, right? And if you're all curious about what's going on here, have some reading. All right. Okay, now this one, why? Oh, I'm hitting the wrong key, that's why. That one's going to here. To, oh, this is also 3.3 volt. Because this one is the LED. The next one is clock. And then the next one is, whoops. The next one is copy. Oh, so that one's wrong. That should not be going there. You should be going to SIPO. And you should be going to copy. Why does this seem wrong? Nope, that's right. I just checked the wiring on my breadboard and all is good. All is wonderful, in fact. All right, so let's go ahead. What's next? Oh, fuck, how do I keep missing that? You click there and then click over there. Thank you. Okay, what's next? This one goes to pin 16. This is data control. This goes to pin 16. Where is it? Right there. And then the next one is reset, which goes to 5. connectors right there. See what a mess that is, right? That's just a horrible mess. I hate doing that. Now, here's the thing. This board is actually going to be fairly large. In fact, it's one of the bigger boards I've ever made. And it just has a lot of components, a lot of voltage dividers, a lot of pins, I've got other chips that I still need to add to this. I want this board to be simple. Now, if we take this, and now these pins, these are called the CS pins. These actually get connected specially to D4 and D2 right there. And this one actually goes down here. Right there. Okay, now let's go ahead and I'm going to save this. I'll run my net list. We're going to go ahead and assign some footprints here. What do I need? What do I need? I need a 1x9. Now this is just your basic pin header, 2.54 vertical 1x9. Now just to make sure we're picking the right one, I'm going to open that up, and then we can actually have a look and see. Okay, that's not what I want. Actually, that is what I want. That's exactly what I want. Okay, so that is definitely, see, that's why we look at these things, to make sure you're picking the right one. That is definitely what I want to use for this. So I'm going to pick a 1x9, and again, 1x9, apply, save, okay, that closes all of that. Then we'll go to here, scroll in, update, why are you? Oh, that's right, I forgot to reassign that, didn't I? Yeah. So let's go to KiCad's boards. Select that ESP32 30 pin. There we go. Save and continue. Update. Good. Now we're all happy and wonderful with non-weird naming. Now let's grab this. Put that there. Let's grab this, move it over here. Now you can kind of see what I wanted to talk about. Now, it's not really a big problem. You see how these kind of lines are crossing and how it's sort of trapped? Basically what this means is that I'm going to have to make a double-sided circuit board. So we're going to have a trace that sort of comes out. All right. For example, from here to here, and then from here to here to here. Now, there's one, and then there's going to be this one, which goes from here to here, and then from here to here, and then there's this one. Now, oh, hey, hang on, all right, I can't go that way. Look at what it's trying to do, right? Oh, I'm making the circuit board at home, so first of all, the traces are not going to be this thin. Second of all, I have no hope in hell of actually being able to get a trace to go between two pins and not short circuit. I'm doing this at home. That's not going to work. So I got to make some sort of a double-sided circuit board, which means putting in a via and then popping it out on the other side. Please give me a via. And continuing, you're supposed to be the other color. Thank you. And continuing it on. And that's fine. However, I've got a lot going on with this board, and the less holes I have to drill, the happier I'm going to be. And I don't want to necessarily have to do a lot of double-sided stuff until I get to these other these other chips I'm going to use. So what I'm actually thinking of doing is maybe making all of these straight lines, and these are all pin headers, so I'm going to actually have wires, cables connecting to these pins. So what I could do is this. I could have all of these cables in a nice clean order going into the pins, and then having the pins do their traces going down through the board over here and up and around and doing all sorts of loops just to get to the other pin. Or I can have all of the traces on the circuit board just be nice, straight, easy to use straight lines, and then I can just do a bit of, on the cable, I can sort of just move the pins around into whatever order I need them. Instead of being neat like that, they'll be connected on one side, but on the other side, they'll be all twisted up and going the other way. Now, there's pluses and minuses to doing that. First of all, if I go with twisted cables and matching pins and stuff like that, I can't just grab a new cable and plug it in. I'm always going to have a custom-made cable. But it makes things a little bit easier on the circuit board. On the other hand, it might be nice just to have a regular cable that's not, I can plug in and use either which way and take care of the work here. I don't know. We'll see what happens. But those are decisions we got to make. However, maybe not just yet. We're going to add a whole bunch of more stuff to this and sort of see what's going on here before we do that. Now, those are just the basics of the headers that are going to be connecting to this. And I'm hoping also that I'll actually just be able to bring this right out. What the hell can track? Grid. Why is my grid? I'm going to increase my grid size a bit here just to make it easier to move some of this stuff around. There we go. Just sort of make sure everything is landed correctly on the grid. Voila. All right. So let's go ahead and continue adding stuff. All right, so I've got some headers. Now these wire connections I've made are sort of just temporary. I'm doing this as I add components just to, why do I keep missing with that? Wire, there. Okay, so that's just some of the stuff that we got to add. Now let's see, what else do I need to add to this? I need to add 12 resistor voltage dividers. Oh my gosh. That's a lot. 12 voltage dividers. I'm going to plop this up here, and I'm going to copy that, and I'm going to put it right there. Actually, I wonder. No, that didn't help. Thought I could do a copy block. There it is, Control C. Okay, fine, be that way. What do I want to do? What do I want to do? And how am I going to do this? So I've got 12 of these things I got to add in, and they're groups of 6. And they're going to come to headers as well. If I do them in groups of 3? No. Sorry, I just had a thought about adding a few more outputs to the whole damn. No, I don't want to do that. I could do that. No, I don't want to do that. Okay, what do I want to do here? Okay, those all have to end up on ground A eventually. No, wait a minute. Yeah. This one is, fuck, how do I keep missing with that? Alright, so that one's going to go there. Now let's see here. One, two, three, four. 1, 2, 3, 4, 5, 6. Okay, these ones are actually going to a different ground. Oh no, they have to go to there as well. Oh, that's right, but they also go somewhere else, which I will add in later. One, 2, 3, 4, 5, 6. Okay. That is in fact 6 voltage dividers. I hate the way KiCad zooms in. I really do. You go there. You go there. You go there. You go there. No, wait. Shit. You go there. Off by one. You go there. You go there. You go there. Oh, you suck. How do I miss that? Oh, it is baffling to me on how I always miss that. It maketh no sense of. All right, now you are the last one. You go there. Okay, good for you. Now, you. No, I don't know where you go actually. One, two, three. Okay. Perfect. All right. So that takes care of those ones. And now, what I need to do over here, how am I going to connect them? Do I want to put them all in a row? So I need to connect these with no more header pins. I'm just wondering if I want to do them in groups of 3. Let's start with a 3, and if it turns out that it looks like it's going to work, then I'll switch it over to 6s. But we'll see how this works first. Seriously, it just refuses to go where I want it to go. I mean, I like KiCad a lot, but sometimes it irks me. Sometimes it just doesn't deserve my attention. Sometimes it makes me sad. Not really, it's just me. I just blame it on KiCad, because who wants to take responsibility for their own mistakes? All right, now. All of these can be connected together. That's just fucked up. those are a bunch of voltage dividers. I think that's going to work. All of these, actually they can all be connected together, come to think of it. Actually, can they? Yes, they can. Let's go ahead and add these to the board and see what that looks like. Okay, first of all, let's add these connectors. These are 254 1x3s, vertical. Yeah, those are the ones. Where the hell, why doesn't it stay highlighted when I click on it? Okay, I want a basic 2.5. No. Alright, that's what I want right there. No, wait, is that the one? This one. No, not that one. Vertical, horizontal. Let's go that way. I wonder if you can do a group select. You can. What was I looking at? DIN 207s. Beautiful. Okay, let's save that. Let's go see what that looks like. This ought to be fun. Jeez. Now you know why I don't do this all in one big schwack anymore. Is there an easy way to do this? Okay. I'm trying to figure out exactly what it did when it laid these out. life easy when it laid them out that way, did it? What? Which one am I trying to find here? This one. Nope. What the hell is this one? Wait, what? It did not lay these out in any... Oh my, what did it do? Oh, you suck. Okay, fine. Start over. Okay, where's R1? Fuck, there it is. Where the hell's R2? Where the hell is R2? There it is. Why is it? Oh, it did not lay these out in any way that makes my life easy, does it? This is going to suck. This is going to take a while to do this. Oh, unhappy. But let's get these laid out and sort of figured out. Okay, so you go to here, all right. R3. R4. Yeah, of course you're over here. R5. R6. R7. Where is R7? There it is. Laying out resistor networks. This is a pain in the ass. R8. R7, where's R8? Oh, fuck. I can't win. I just can't win. I didn't realize I already spun them, I guess. Please stop it. See, sometimes it just doesn't do the right thing and it just makes you sad. R11. R12. R13. so you decided to go out of sequence now. What? Have I done something horribly wrong? Oh, they're not going in sequence. Oh, you dirty scoundrels. Wait, are you? Oh, I just got a group of resistors up here. That's why it's all messing me up. I'm going to move a bunch of these, obviously, but let's just get everything sort of lined up. So I can at least see what the hell's going on here. 16, where's 17? 17. 18. 19. 20. Two. 23. Almost there. And 24. Alright, now, what's the best way to lay all of these out? What is a good way to lay out a bunch of resistors? Oh, I like that. That might work well. That actually works very well. And it stays within the confines of the board. Nice. Two, 4, 6. Okay. 1, 2, 3, 4, 5, 6. Oops. I think I might have to spin these ones around. Yeah, let's put those in a slightly different order. All right, now it'll work well. Yep, I like this. This is going to work well. Make my life easy. Come on. Nice. Might have to move them a bit, but that's okay. Okay, I think that'll work for all my resistor networks. My voltage dividers. All right, now let's see VSIs. I gotta remember how I do this. 0.5. This is at 1.2. What? Oh, too many decimals. All right. Hang on, why is that pin empty? Oh, that's why it's a ground pin. that's not the right one. I wanted to use 0.254. Oh, that's the wrong one. That's why. Good enough. Sometimes they just never want to quite cooperate and click quite where you want them to. It's just so annoying. There we go. Come on, just go where I frickin' tell you to sometimes. It's just really annoying. Why are you clicking way out there? Thank you. Why is that so hard to make a shape like that? I don't think these are going to work quite there. I'm going to have to move these ones up. Yeah, that's already a bit of a problem. All right, that's fine. Move them out a bit. Why? All right, those are connected. Those are connected. Those are all connected. Where are you going? To here? There. Don't be like that. Why fucking... Thank you for cooperating, you bastard. Alright, those are connected. So let's see what that looks like. That is a lot of resistors. And I'm already unhappy with what I've done. So what I'm going to do, I'm going to change a lot of this already. That happens. So weird. Did I move them on a different grid or something? Why the fuck won't those things line up? Thank you. Why the fuck won't you line up? I hate it when it does that to me. Alright, I think this will work. Now let's move everything over a bit more. It's not going to work, but I'm going to go with it. Okay, yeah, this will work. So the reason for the change is I want all of these holes to be lined up when I drill them, and it's just easier if they're like that. I'm going to make another change. I think I'm seeing a better way to do this now, too. Keeps everything in a line. Easy to drill and easy to connect. Oops. Let's move these and see if I can get them to line up. There. Now we're talking. Well, that makes life easy. And I'm going to stick with, I'm actually going to change them out to 2 4s, I guess. That'll be cool. All right, that'll work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nope, not 2 4s. What am I thinking? A 4 and a 2, I guess. I got 2 wasted relays. Okay, I think that's going to work very, very well. Now we're just going to connect all the grounds. No, we're going to connect all these first. Come on. Thank you. Thank you. Always got to make things difficult, don't you? Probably means I can move them all closer, but I'm not going to. I think that's just fine. Now, let's hook up all of these. I'm going to do a big ground plane, though. That's what I was going to do. That's going to be fun to do a big ass ground plane like that. Alright, so let's see here. I'm not going to do the ground plane yet. Do I want to move those over? I could move these over. Do I have enough clearance? Yeah, I've got clearance. Considering this is actually all going to be up, I could move them over. Should I move them over? I could move them over. Let's move them over. I don't need to move them over. I mean, my board, they're already within the confines of the, I could move those over. What if I move those over? Interesting. could move all of these over, or rearrange these a bit to get a better line on the traces, and then move these closer, and that would save me some size there. It's not a bad idea. And then I still have all the room I need over here to build out the rest of it. That's a lot of resistors, eh? Yeah, I'm going to move them over. Why not? Well, let's just see what else I can do for this. But I am getting hungry. I feel like it's curry time. All right. Well, I am definitely hungry. It's 12:30. It's time for me to food myself. Good progress, though. I like the way this is coming out. It's going to be not a bad board. This is going to move. These will move. Still have to do something different with them. Yep, I like it. I like the progress so far. Let's make sure this will all be uploaded into my GitHub repository here in a few minutes. But as it is, I think I'm going to wrap up this stream. I think we made some good progress with those resistor arrays, those resistor networks, voltage dividers. So many voltage dividers. And everything's still one-sided. That's good. I could do this on a one-sided board. That's good. But actually, even these, if I change them around, and then just change my wiring, still a single-sided board. However, I am going to run into a problem when I try to hook up the I2C, because I2C is using clock and SDA, so that's just, that's fine. I can actually go this way. This does have the potential to be a single-sided board. Maybe. God, that would be awesome if I could do that. I think I can. Anyways, I'm going to wrap up. I'm going to go make myself a curry. Thanks for watching. I'll probably come back a bit later after I've done a bit more work. We'll see how things go. Awesome. All right, well, thanks for watching, y'all. Subscribe, turn on likes, all that good stuff. I'll see y'all later. Bye-bye.
Shut up and sit down.